This is page 1 for experiment number 5. So just please take a screenshot for all of the pages. So this is page 1, and this is part 1 of page 2, half of page 2. Okay, and this is the other half of page 2, this one. And this is the first half of page 3. Okay, so please do take note of the corrections here. Okay. So next is this is the second half of page 3. Okay, so for a while, there we go. Okay. So guys, kanina yung graph, no? Kung ano ni siya, this is in LT Spice na. Okay? So your graph is already in LT Spice, no? So just take a screenshot or a snapshot of the graph, no? So you need not to plot this by hand, okay? Or plot this by hand in a piece of paper. So LT Spice takes care of that, no? So I believe this was not updated by the one creating the manual. So let me just again tell you in advance that the graph that you will be putting in your final report is the graph that is exported from LT Spice. So no need to draw it by hand. Okay, no need to draw it by hand. So should I go back? Kinsay na kuan? Kinsay na miss atong kuan?
Pwede page 1, sir.
Okay. Hi, Sophia. So this is page 1. Hala, uniform siya. Klaro kayo. Pustanay.
Oo, wala.
Wala. Okay. Sayang. If nag-uniform ka, flat 5 ta. Parehata mong planos.
Wala. Wala, sir. Thank
Okay.
you, sir.
Maura?
Yes, sir.
Okay, very good. So how about the others? Do you want me to go back to a certain page or something? Just speak out, no? Okay, so wala na, no? So we can proceed with the discussion proper as well as the demo. Okay, so a while back, I have discussed to you the basics of AC analysis or AC circuits, diba? So hopefully you have also viewed or watched the video lectures, the last 2 of them that I have posted in our group. And we will just be discussing some of the things that might be relevant for today. No? So let me just go back to the very basic. Okay, so just a quick recap lang. So when you have an AC circuit, it is usually being supplied by a sinusoid. Okay, a sinusoidally varying voltage, diba? So it's an oscillating sort of signal in which we can basically model this as V of t equivalent to Vm sine omega t. Okay, so some key things here. Your V of m is actually the amplitude, right? So when you say amplitude, that's just the maximum and minimum value, no? So this is the amplitude V of m. So this is positive V of m and this is negative V of m. Okay, so we can generalize this, diba, including the phase shift of a certain sinusoidal signal. So for example, V of t could be equivalent to Vm sine omega t. So for example, plus phi. So one of the main tools that we'll be using in trying to analyze AC circuits is again the frequency domain, diba? So when we say frequency domain, we are simply changing our sinusoids or sinusoidally varying functions into complex numbers. And upon doing that, for instance, we would like to obtain the phasor of your V of t. So it's usually represented by a capital letter with a sometimes with a arrowhead in above of it or above the letter. So you simply take the amplitude as well as the angle. Okay, so that's basically it. No? So we will usually be analyzing AC steady state circuits using phasor analysis because it's much easier to manipulate as compared to your sinusoidal functions. No? So upon or next to that, another parameter that is also important is your impedance. Okay, so let me go back a bit. No, in DC, so in DC, we know that using Ohm's law, our resistor is simply the ratio of the voltage divided by the current, right? So the resistance is basically just the measure of the opposition of flow to direct current. Now we have a similar quantity or parameter here, no, in steady state AC, and that is called your impedance. Okay, so analogous to this is in AC, you have your impedance. Okay, so basically your impedance is a complex quantity which is given by the ratio of your phasor voltage divided by the phasor current. So since your Z is a complex number, it could also be represented by two components, diba? If we write it in rectangular form. So that would be R plus J of X. Okay? So your R here is the resistive element of the branch. So this is the resistive element of the branch. So this is a real physical number. This is a real number, no? That is attributed to, again, the resistive component of the branch. Okay. While your X, this is dilinin mo X, ha? Okay, Sophia, dilinin mo X na boyfriend or something, no, kay kanang kuan man. This is circuits, okay? So I'm just trying to break the ice here, no, kay medyo hilom ang class, no. Hindi na si Planos kay paspas ba kay, no. So si Sophia flat 5 day kanya, si Planos kay 5.5 na, no, kay kuan paspas kay nakatingo ganina.
Yes, sir.
So isa kang alamat, Planos. Wala nang makakapigil sa iyo, no. So X again is your reactive component. So it could either be inductive. So when you say inductive, your X is simply equivalent to omega L. Okay? Or positive J omega L. So this is your inductive reactance. And if it's capacitive, this quantity is equivalent to negative J divided by omega C. Okay, so your impedance is always a combination of a real component and an imaginary component. So then the imaginary component is again either a capacitor or an inductor. So we can represent this in our circuit as simply a series connection of a resistor and an inductor, or a series connection of a resistor and a capacitor. So there's that. No. Also, in your AC circuits, you will also come across purely inductive, purely capacitive, and purely resistive elements. No? So that is when the branch, for instance, if you have a branch here, so for instance, for a purely resistive element, so take for instance X here is equivalent to 0. So we can say that this branch, the impedance of this branch is purely resistive. So meaning the average power, it draws average power all the time. So that is one of the interpretation to this. If you were to relate this to power analysis later on. So this is what we will be examining for this experiment. Okay. So basically for this experiment, we will be focusing on a series, a connection of a sinusoidal voltage given here, connected in series with a resistor or two resistors. Okay, so if this could be V, let's say angle phi, and this is R1 and this is R2. Okay, and so sorry for the banging. No, so there's a construction going on in our neighborhood. So just bear with me. No, this won't be long. Don't worry. So your I here, you also have an I flowing here. No? Okay. So the reason that the phase angles of your voltage and your current are the same, it's because in AC or in a purely resistive circuit, the voltage and the current are said to be in phase. Okay. So meaning they peak at the same time. So for example, I were to have a voltage here going that way. Okay. And if you were to superimpose the graph of your current, it would go something like this. No? So it's not drawn perfectly, obviously. So let me get a better drawing here. And again, sorry for all the banging. No? So I can't really control what the neighbors are doing. So this means to say that your voltage and your current are said to be in phase. Okay. So so it means that they would peak at the same time, and that if you were to draw a phasor diagram, no? So this is in the time domain. This is in the time domain, and if you were to draw it in the frequency domain, you would have something like this. No? Okay, so if this is the voltage phasor V, so it has a certain angle here, also phi. So your phasor current will be in phase. Okay, so this is your I. So that's what we will be performing today, no? Or you will be performing today. So let me just show you a quick demo, okay, of what to do in LT Spice. So let me just transfer my shared screen here to LT Spice. And what can you see, Sophia? Is it already in LT Spice? Or na pa siya, nag-load pa siya?
LT Spice na, sir.
Okay, so very good. So so firstly, we construct our circuit. No, so if you can take a look at your manuals, so it's actually just a series circuit of two resistors connected to some source. Okay, so we may start with the resistors. No, so this is R1 and this is R2. Okay, so we just rotate R2, Control R, and then we just get our standard voltage. No? So it's the same voltage source. Galing lang ang iyang forcing na function is different. Okay? So we click this component here and then look for the voltage. Okay? So as per usual, you connect everything. So this is just connected in series. No? Again, you can check this. You can take a look at the circuit diagram in our in the screenshots that you have just did previously. No? And again, don't forget the ground. Okay, always place the ground. No? So this is your ground, and let's plug in some values. Okay, so for your R1, again, you right click, diba? So what is the value of your R1? Please dictate na sa katong na cancel ang screenshot. What is the value for your R1? Please ilagay ito siya. It's in the, I believe it's in the first page. Okay. Sige, ang unang makaingon kay flat 5.
1
Hangol
kilo
kay
ohms,
flat 5.
sir.
Hala, di na pwede, Sofia, kay flat 5 naman daw daan, di ba? So,
Band na ko.
band na ka, kay di na pwede ka ng flat 10, no? So, it's absurd. So, 1K, di ba? And then, what is the tolerance, the percent tolerance? I think it's 5% or 5, no? I think it's 5.
5%, sir.
Ang power rating,
1/4, sir.